Johnny here with Simpson Math. In this video, we're going to talk about surface area and how to calculate it. Alright, so for this example, I have just this function, y equals f of x. It makes this nice little arc. And I'm going to take that arc and I'm going to rotate it about the x-axis. Now, we're not talking volume here. So the previous videos, we were talking about taking a plane, so maybe the region between this arc and the x-axis, or the region between two arcs. That's not what's going on this time. I'm just taking this arc and I'm rotating it about the x-axis, and that creates a shape, and I'm going to calculate the surface area of that shape. Alright, so here we go. I'm going to rotate it. Looks something like this. So it's the same shape, it's been rotated about the x-axis, and I want to find the surface area of that generatrix. A generatrix is just that shape that's been formed by taking that line or that arc and revolving it about the x-axis. To me, it kind of looks like it creates a vase, but it's not the base of the vase, it's not the top of the vase. It's just the thin layer of paint on the outside of that vase. There's no width to it either. This is just a line here. It's there's no width. All right. Well, if I took it back to, a trivial form, if I just had a surface area of a piece of paper, we could find that area by taking the base and multiplying by the height. Piece of paper, surface area, base times height, or length times width, base times height. If I take that paper and I kind of do what we've done here, and I create this cylinder, something like that, you can see it's, there's a hole in there, and the paper is that thin layer of maybe paint on the vase. And if I wanted to calculate the surface area, well, notice my base is now a circle. So it's just the circumference of the circle, 2 pi r, being multiplied by the length of that object. Okay, so it's the same idea here. This base of my object is now a circle. So I'm just going to take the circumference of this circle and multiply by the length of the object. Well, the length is this arc length. So in a previous video, we were tasked to find the arc length, so we know how to do that. And then the circumference is just going to be 2 pi r. So the 2 pi is the constant we can ignore, and really I just need the radius of all these circles. Well, notice the radius of all of these little circles will just be that y distance, or the function itself. So we have a nice, pretty formula for calculating the surface area, and that's just the integral of 2 pi r, where r is the function, times the length, where this is the formula we learned in a previous video to calculate the length of an arc. Integral 2 pi r times the length. Bam. All right, let's just jump straight into an example. What is the surface area of the surface using this function, 2 roots of x, over the interval 1 to 3 as the generatrix and the x-axis as the axis of revolution? Alright, so I know what that shape kind of looks like. It's the little teapot arm that goes off into quadrant 1. The 2 is just the vertical dilation, kind of stretches it up a little bit. And I'm just looking at it from the interval 1 to 3. I'm taking that arc length, not that region, just that curvature of the arc. And I'm going to take that and revolve it about the x-axis. Okay, well, we have a formula. I'm just going to throw it straight into this surface area formula. The surface area is the integral of 2 pi r. I'm going to take the 2 pi out of the integration process. I'm integrating along the x-axis, or along that interval 1 to 3, times the radius, 2 pi r. Well, my radius is just going to be that y distance, the function itself. So the function in this case is 2 roots of x. And I still need to multiply that by the length, or the arc length. Maybe I'll call that L. Now I'll just go back into the formula. The arc length formula says it's the square root of 1 plus the derivative of f squared, and we are doing this with respect to x. Okay, so to continue with this surface area formula, I will need to find the derivative of f of x and then square it. So let's do that real quick. If f of x is 2 roots of x, I can find the derivative. The coefficient just kind of stays there. The derivative of x to the 1/2 power, the power of 1/2 comes down. My base stays the same, but I do subtract 1 from the power, so it's now negative 1/2. Cleaning that up, the 2's reduce, the x goes in the denominator, and it's the square root. So I have 1 over the square root of x as the derivative of f of x. Oh, but I need that value squared. F prime of x squared is just this value squared. So I can square both the numerator and denominator, and I'm going to get 1 over x. That was convenient. Okay, I think I'm ready to throw this into the formula. I think I'll also take this 2 constant out of the integration, so I have 4 pi out front. And all I did here was find f prime squared. So I'm just going to rewrite my formula. I have 1 plus, and I found that to be 1 over x. Okay. Still need to integrate. I think I can clean this up some more. Because they're both square roots, I can multiply the radicands. So the x can distribute into there. So I have the square root of x plus 1. With respect to x. It's been a while since I've done integration. Maybe we can use some substitution. If I let u be the radicand, x plus 1, then du is simply the dx. So I can now switch this over into u land, but the limits of integration are with respect to x, so they too need to be switched over. And I have a little relationship between x and u right here. So when x is the lower limit 1, then u is just 1 plus 1, 2. When x is the upper limit 3, then u is 4. So I'm going to rewrite my integration in u land. So I have surface area equals 4 pi times the integral, now from 2 to 4, of the square root of u du. Oh yeah, I can integrate this. It's just a power rule for differentiation in reverse. So the u to the 1/2 power is going to become u to the 3/2 power. Multiply out front by the reciprocal, 2/3. I still have a 4 pi. And I need to evaluate this from 2 to 4. Let me walk through that one more time. Make that u a little bit prettier. That's u to the 1/2. So you up it by 1, 3/2. Multiply out front by the reciprocal, 2/3. Perfect. So out front I have 8 pi thirds, and then I need to evaluate u to the 3/2 with a 4 and a 2 and do the subtraction. Plug in the 4. So I have 4 to the 3/2 power minus 2 to the 3/2 power. Oh, those are pretty numbers. I can continue. Let's see here. Square root of 4 is 2. 2 cubed is 8. Two cubed is 8. The square root of 8 is the square root of 8. Oh, I can go a little bit further and clean up the square root of 8. I know that one is, or simplifies to 2 root 2. I have the answer, but I'm just now simplifying. And for fun, I see that they're both even. They both have that power factor of 2. I could factor it out. I think I'll stop there. We have 16 pi thirds times 4 minus the square root of 2. That is the surface area of that generatrix, that shape that was formed by rotating that arc about the x-axis. All right, go practice some more, and I'll see you in the next video.